Tonight, you're going to travel to a place where gravity is optional and time has no forward direction. You'll sit down for dinner with relatives who passed away years ago, and in the moment, having a casual conversation with them will feel completely normal. Then you'll jolt awake. Your heart will be racing, and for a few disorienting seconds, you'll struggle to figure out which reality was actually real. This happens to every human being, every single night. The question is whether these vivid hallucinations are carrying secret messages from your subconscious, or if your brain is just misfiring in the dark. In 1899, Sigmund Freud proposed an answer. He argued that dreams are a highly disguised code, acting as a pressure valve for our deeply suppressed wishes and forbidden desires. According to his thesis, you couldn't just interpret these nocturnal stories yourself. It required a trained psychoanalyst to untangle the bizarre imagery and reveal the hidden meaning beneath. That idea dominated psychology for decades, until Harvard neuroscientist J. Allen Hobson published a paper in 1977 that dismantled Freud's entire framework. Looking at this schematic of the human brain, Hobson's biological theory becomes clear. He found that the primitive brainstem fires random electrical signals upward during sleep. The rational, storytelling part of your brain then desperately scrambles to stitch that chaotic noise into a coherent narrative. Modern brain imaging now reveals that while the signals begin as the biological noise Hobson identified, the brain uses that noise to process the very psychological data Freud first explored. We used to think of sleep as a time when the brain shuts down to rest, but modern scans show that during REM sleep, the phase where dreaming happens, your brain is just as electrically active as when you are wide awake. Looking at this 3D map, the default mode network, handling imagination, lights up, while the amygdala, our emotional center, burns bright. Simultaneously, the hippocampus pulls up emotional memories, routing fragments to other regions to be sorted. Dreaming of an ex-partner or a lost loved one occurs because the hippocampus prioritizes files with heavy emotional weight, sorting through grief to reorganize your long-term memory. This constant replaying and reorganization of memories allows the brain to strengthen new information while gradually processing the associated emotional pain. This transforms a confusing nightmare into a structured biological mechanism for moving forward. But processing emotions is only half the job. Finnish cognitive neuroscientist Antti Revonsuo argues that dreaming also serves an ancient survival function. He proposed the threat simulation theory. Those universal nightmares we all have, like being chased through the dark, are evolutionary software programs. It runs threat response drills, like freezing up during an exam, in a safe environment, so your nervous system is prepared for real danger. Your brain is so deeply invested in these physical simulations that it sometimes misfires right as you're falling asleep. It sends a signal that you are falling, your body panics, and you experience a violent hypnic jerk that wakes you up. The shape of your dreams is driven by biological noise, just as Hobson thought, but the function of those dreams provides a vital psychological survival tool, capturing the deep meaning Freud was looking for. If the dreaming brain is this active and this functional, it raises a new question. Are we forced to be passive passengers, or is it possible to communicate with the mind while it's in this state? In 2021, a research team at Northwestern University set out to test this. They attached intricate EEG nets to sleeping participants to monitor their exact brain states, attempting a real-time dialogue with someone deep in REM sleep. Once the monitors confirmed a subject was fully immersed in a dream, the researchers asked them a simple audio question. What is 8 minus 6? The sleeping subject heard the math problem inside their dream, solved it, and intentionally moved their eyes from left to right exactly 2 times. The monitors recorded the correct answer. This experiment proved that a dreaming mind isn't entirely cut off from the outside world. It maintains a specific level of waking consciousness, capable of reaching across the barrier of sleep to interact with reality. The subjects in that experiment were successful because they were in a state of lucid dreaming, the moment a person realizes they are dreaming while still asleep. Looking at this cross-section of the sleeping brain, we know exactly when this happens. During normal REM sleep, your prefrontal cortex, the rational, logical part of your brain, is dim. But the moment lucidity hits, this area suddenly reactivates. Once that rational center is back online, you gain conscious control over the dream environment. You can use it as a therapeutic sandbox to confront recurring nightmares, practice physical skills, or actively regulate your anxiety. And you can train your brain to do this. Keeping a daily dream journal and getting into the habit of asking yourself if you're dreaming during the day actually trains your neural pathways to trigger that lucidity at night. The sleeping brain is a functional, interactive environment, one where you can choose to engage with your subconscious rather than just observing it. You have the power to take the wheel.